In the last class, we already discussed about the differential equation, right? Now, our next chapter is vector for class 12th. Vector algebra. Let us see what is the vector and what we will learn in the vectors. So, first of all, we need to discuss about the definition of vector. How can we define a quantity is a vector? So, there are two different things in a quantity. First one is scalar and second one is vector. The scalar quantity which has magnitude only, but the vector quantity represents magnitude with direction. Magnitude with direction. This type of quantity which represents magnitude with direction is called the vector quantity. Let us see, if I say we go 15 kilometers, this is scalar quantity because we have magnitude only. But if we decide we have to go 15 kilometers towards north, 15 kilometers towards north, that means we have magnitude 15 kilometers as well as direction towards north, right? So this is the vector quantity. So if we have a quantity which includes magnitude and direction both is called the vector quantity. For example, force. If we apply a force on this whiteboard, so direction is defined. Where we apply the force, in which direction we apply the force. So force is a vector quantity, right? But speed, if I say the speed of a car is 40 km per hour, if the speed of car is 40 km per hour, means speed is scalar quantity. This is not a vector, scalar quantity. But if I say velocity, a rocket launched at the velocity of 200 km per hour. So direction is defined here. So velocity is a vector quantity, but speed is a scalar quantity, right? So now we can say that a quantity, a physical quantity which includes both magnitude and direction is called the vector quantity. Then how can we represent a vector? Let us see. If we have to represent a vector like point A to point B, direction is already defined. From point A to point B, means A is the initial point and B is the final point. This vector can be written as AB and arrow on that. This is called AB vector. AB vector is what? Direction is defined. But if you say AB, what do you mean by AB? AB can be written as BA also. AB means what? Scalar quantity. AB the distance, length, which is scalar quantity. But if we draw an arrow sign above the AB, so this is a vector quantity. So we can say that it is a vector quantity, but this is a scalar quantity. This includes magnitude only, but this includes magnitude as well as direction. Direction what? From point A to point B. This is the direction. Now, right? Now this is called AB vector, right? So now you know what is the definition of vector. How can we define a vector? And this type of quantity are the vector quantities. It's very simple, right? Now let us see how many types of vectors are there. It's very simple concept. How many types of vectors? If you applied a force on this whiteboard of 0 Newton, then nothing displaced from this point. So this type of vector quantity is called the null vector or zero vector. Null or zero vector means the vector quantity having the direction but magnitude is 0, having a direction but magnitude is 0, means the velocity is 0 meter per second. The direction is defined. The force is 0 Newton. The direction is defined, but magnitude is 0. In this case, this type of vector quantity is called the zero vector or null vector. The magnitude of a vector is 0, called zero vector, and it is represented by a vector. Sorry, zero vector. A vector can be written as zero vector. Zero vector. This is the zero vector. Second one is unit vector. What do you mean by unit vector? The magnitude of a vector is 1. This is called the unit vector. We will discuss the unit vector in detail in the next topic. But you must know the definition. The magnitude of a vector is 1, called unit vector. And you know how can we represent a magnitude? If you have a vector A vector, how can we represent the magnitude? Magnitude can be represented by the modulus. So A vector mod is called the magnitude of A vector. This can also be written A only, right? If we have the magnitude 1, if you have the magnitude of this vector 1, so this A vector is called the unit vector because magnitude is 1. We'll discuss how to find the magnitude in the next topic, right? So these are the vectors, null vector, unit vector. You can say parallel vector. What do you mean by parallel vector? Parallel vector, if you have two straight lines in parallel, no matter what are the magnitudes here, magnitudes may be different. Let us see, the magnitude of this vector is AB and the magnitude of this vector is CD. So their length are different, so magnitudes are different, but the direction is same. So we can say that AB vector is parallel to BC CD vector. AB vector is parallel to CD vector. We can also say that both vectors are equal. So we can multiply with any scalar quantity with this vector. The directions are same. For example, if I say I will go in this direction. From this line and from this line also. So both lines in same direction, right? In the same direction. So both vectors are same. Both are called the parallel vector or the same vector. We can also say this one as collinear vectors. These points AB and CD are not collinear, but directions are same. So we can say that these vectors are collinear vector as well, right? If you have a parallelogram, then let us see if we have a parallelogram. So in this case, let us see if ABCD is a parallelogram. We can say that AB vector is equal to DC vector. We can say that AB vector is equal to DC vector. We can also say that AD vector is equal to BC vector. AD vector is equal to BC vector. AD vector is equal to BC vector and DC vector is equal to AB vector because magnitudes are same and the directions are same. The both straight lines AB and CD have AB and DC having same magnitude, equal magnitude and in the same direction. But if you say this line is CD, so AB vector is not equal to CD vector. AB vector is just negative to CD vector. But AB vector is equal to what? DC vector. Directions are same here. But in this parallelogram, if you have this parallelogram PQRS, then if you have PQ and RS, so the PQ vector is not equal to the RS vector because directions are opposite, not exactly same. In the opposite direction, we can write the negative sign here. You can take PQ vector is equal to minus RS vector. Negative sign you can take because the direction is just opposite. Here the direction RS. If you take SR, then SR vector is equal to PQ vector. Right? So these are all about the direction. Vector quantity is all about the direction only. Right? Now let us see how can we find a resultant of a vector. How can we find the resultant? That is very important concept is called the triangle's law. Let us see the resultant of the vector quantity. Resultant of the vector. एक vector का resultant. Right? How can we find the resultant of the vector? You know what is the difference between distance and displacement? What is the difference between distance and displacement? If I say you go from point A to point B and from point B to point C. If we go from point A to point B and from point B to point C, so finally you went from point A to point C, but via B. This is called the distance traveled. What is the displacement of this? Displacement is just joining the starting point to the end point. That is called the displacement. If we draw the initial point to the final point, this is the initial point to the final point. Initial point to the final point. Initial point to the final point. This is called the displacement. You know, distance is a scalar quantity, but displacement is a vector quantity because displacement represents the direction as well. In which direction you went, right? So here we can say that the distance AB vector plus BC vector is equal to AC vector. This is very important triangle law. This is called the triangle law of vector. This is called the triangle law of vector. Very important and very simple. You can see the direction here, AB, and then BC. So the terminal point of the first vector is same as the initial point of the second vector. Then we can find the resultant as starting point to ending point. So we can say that AB vector plus BC vector is equal to AC vector, right? If we say that, like if we have a triangle, in which this vector is small a vector and this vector is small b vector and this vector is c vector, what is the relation between a vector, b vector and c vector? What is the relation between a vector, b vector as well as c vector? What is the relation? Let us see. This is the starting point. You have to see the direction. Direction is what? This is the direction. And then ending point of this and starting point of the b vector the same in this direction. So you started from this point to this point finally. You started from this point to this point. So finally you covered the distance of a vector plus b vector, that will be equal to displacement c vector, right? So in this diagram we can say that a vector plus b vector is equal to c vector. You can use this concept in pentagon, hexagon, quadrilateral, octagon, decagon, everywhere. You just need a triangle and see the direction. You just need a triangle and see the direction for that, right? Now, let us see if I have a question in a parallelogram. If we have a question in a parallelogram like this is a parallelogram, and in this parallelogram we considered two adjacent sides as A vector and B vector. we consider two adjacent sides A vector and B vector. So what is the vector quantity of diagonals? How can we represent, how can we relate the diagonals with A vector and B vector? This is the question. So let us see, we have a diagonal AC. Now what do we mean by AC vector? What do we mean by AC vector? AC vector is just A vector plus B vector. This is called the AC vector, right? So the first diagonal AC vector can be written as A vector plus B vector. Now what about the BD vector? What about the BD vector? Let us see, if we draw another diagonal, that is BD, what about the BD vector? Now in this triangle BD, BD include in a triangle ABD. So you know this vector is B vector, so this line is just parallel. So this vector is also B vector, because you can say that both vectors are equal. If two straight lines are parallel, same magnitude, then both vectors are equal. So this is B vector, this is also the B vector, right? And this vector A vector. Now you can see the triangle ABD. You can see the triangle ABD. What is the triangle ABD? You can see the triangle ABD. And in this triangle, if you say this is the direction, if you say this is the direction of BD, so we can say that in this triangle AB vector plus BD vector means you started from point A via B, you end at point D. So what we mean by AB vector plus BD vector? This is just opposite AD vector, right? But we have to find BD vector here. So AB vector can be written as A vector plus BD vector is equal to AD vector can be written as B vector. So finally BD vector can be written as B vector minus A vector. This is called the BD vector. So we can say that BD vector is the second diagonal of the parallelogram, that you can say B vector minus A vector. But in the opposite direction, DB vector can be written as A vector minus B vector. DB vector is called A vector minus B vector. This is called DB vector and this is called AC vector. So these two are the diagonals of the parallelogram. If you have two adjacent sides in a parallelogram given, then you can find both the diagonals. So first largest diagonal is called A vector plus B vector and the smallest diagonal is called A vector minus B vector in the opposite direction. This vector is called DB vector, right? This law is called the parallelogram law of vector. This is called the parallelogram law of vector. This is called the parallelogram law, right? Now let us see if we have a question in some other polygons like pentagon, hexagon and all the things. You can just use the triangle law. Triangle law is a very simple concept and you have to use the triangle law everywhere. Let us see, we have a hexagon, we have a regular hexagon. If we have a regular hexagon, if we have a regular hexagon. Let us see, this is the regular hexagon in which two adjacent vectors are given, A vector and B vector. Can you represent each side with A vector and B vector? Can you relate each side, remaining side CD vector, DE vector, EF vector and FA vector with A vector and B vector? How can we represent this? If you have to draw this line, let us see, this vector is B vector, so this vector can be written as minus B vector. You know, this vector is minus B vector because direction is just opposite and lines are parallel. And what about this vector? This vector is called the minus A vector. Direction is just opposite, A to B and here due to it, A to B and B to E. Direction are just opposite, so we can write this vector as minus A vector. So now finally we have to find these two vectors. So if you draw this line, this vector can be written as A vector plus B vector. We have to find this vector, so we can draw this diagonal as well. So this vector can be written as 2B vector. This is called 2B vector. Because this is B vector, this must be 2B vector in a hexagon, in a regular hexagon, right? Now, we have to find CD vector. So in triangle ACD, we can say that AC vector plus CD vector is equal to AD vector, right? So now AC vector can be written as A vector plus B vector plus CD vector is equal to AD vector can be written as 2B vector. So finally, CD vector will be 2B vector minus B vector, that B vector minus A vector. This is called the CD vector. CD vector, you can say B vector minus A vector. This is called the CD vector, right? So now you can say A vector, B vector minus A vector minus A vector minus B vector. Now what about FA? FA, the direction is just opposite to the CD vector. So this can be written as A vector minus B vector. Because this is B vector minus A vector, you can take minus sign before that, you will get A vector minus B vector. So we relate all the sides of the hexagon with two adjacent sides, right? Now we have one very important concept in this hexagon. What is the concept? Let us see. If you add all the sides of a polygon in the same direction, what you will get? Let us see. If you added AB vector plus BC vector plus CD vector plus DE vector and plus EF vector, what you will get? AB vector plus BC vector plus CD vector plus DE vector plus EF vector plus FA vector. Starting from point A and end with point A. What is the displacement? 0. You started from point A and end up to point A. The displacement is what? 0. So it must be 0. Let us see. AB vector is A vector, BC vector is B vector, CD vector is B vector minus A vector, DE vector is equal to minus A vector, and EF vector is equal to minus B vector, and then last one is FA vector, and FA vector is equal to A vector minus B vector. You can see here B vector is cancelled with minus B vector with B vector, A vector with minus A vector, A vector with minus A vector. But you will get 0 vector. This is not the 0 only, this is 0 vector. 0 vector represents the direction starting from point A to end with point A. So this law is called the polygon law of polygon law. Polygon laws say that in any polygon, if you start from a point and end with the same point, the sum of all the vectors becomes 0 vector. In the triangle also, in a triangle if I say we have AB vector and BC vector and CA vector started from point A and end with point A. So you can say that AB vector plus BC vector plus CA vector equal to 0 vector. So we get AB vector plus BC vector plus CA vector equal to what? 0 vector. This is called the polygon law of a vector, right? Now we will discuss some more questions in the next tutorial. This is the basic concept of the vector. Thank you.